Our story begins a long, long time ago in ancient times. People dreamed of creating artificial beings. The Greeks told myths about mechanical men like Talos, a giant bronze robot. Fast forward to the 1600s, and thinkers like René Descartes wondered if animals, and maybe even humans, were just complex machines. These ideas planted the seeds for AI, but it would take centuries for technology to catch up. In the 1940s, when computers were massive, slow, and could only follow basic instructions, they weren't intelligent in any way, but a few scientists started asking, what if they could think like us? Alan Turing, the father of modern computing, posed a simple but revolutionary question: can machines think? In 1950, Turing proposed a test. If a machine could have a conversation that was indistinguishable from a human's, would that mean it was intelligent? This set the stage for an entirely new field: artificial intelligence. By the mid-50s, AI wasn't just science fiction, it was a serious academic pursuit. A group of researchers at Dartmouth College, including John McCarthy, coined the term artificial intelligence. They were wildly optimistic, believing we'd have human-level AI within a few decades. They thought, we just need faster computers and better algorithms. But reality had other plans. Teaching machines to think turned out to be much harder than expected. Early AI systems like Eliza, a chatbot that mimicked a therapist, could hold simple conversations, but they weren't really thinking. By the 1970s and 80s, progress stalled. Governments and universities pulled funding. The AI hype train had hit a wall, and we entered what's now called the AI winter. The dream of intelligent machines seemed to be slipping away, and many scientists moved on to other fields. Then, in the 90s, AI made a comeback. The secret? Data. Lots and lots of data. Instead of trying to make machines think like humans, scientists used something called machine learning, teaching computers to recognize patterns. This shift was crucial, allowing machines to improve through experience rather than relying solely on pre-programmed rules. This was the era of machine learning. Neural networks could analyze data and find patterns which made them perfect for generative tasks. For example, in the 1990s, researchers used them to generate simple images and text. It wasn't exactly Picasso-level art, but it was a step in the right direction. Still, progress was slow, but not for long. And in 1997, AI shocked the world when IBM's Deep Blue defeated world chess champion Garry Kasparov. This wasn't just a game, it was a sign that AI could outperform humans in complex problem-solving. The 2000s saw an explosion of data and computational power. Companies like Google and Facebook started using AI to recommend videos, recognize faces, and even predict what you want to buy before you do. AI was no longer just a theoretical concept, it was shaping everyday life. Then, in 2011, IBM's Watson stunned the world by defeating Jeopardy champions Ken Jennings and Brad Rutter. Watson wasn't just recognizing patterns, it was understanding language, making connections, and answering complex questions in real time. But the biggest shock came in 2016 when an AI called AlphaGo beat a world champion in the ancient game of Go, a game so complex it was thought to be untouchable by computers. Unlike Deep Blue, AlphaGo wasn't just following programmed strategies, it was learning, adapting, and even surprising its own creators with moves no human had ever considered. In 2018, OpenAI introduced GPT, or Generative Pre-trained Transformer. This was a new kind of AI model that could generate human-like text. The first version was impressive, but it was GPT-2, released in 2019, that really blew people's minds. It could write essays, poems, and even news articles that sounded like they were written by a human. Then came GPT-3 in 2020. With 175 billion parameters, basically the building blocks of its brain. GPT-3 could do things no one thought possible. It could write code, answer questions, and even create entire stories. It was like having a super smart writing assistant at your fingertips. But generative AI isn't just about text. Tools like DALL-E and Midjourney can create stunning images from simple text prompts. Want a picture of a robot eating a taco on the moon? Done. How about a Renaissance painting of a cat astronaut? No problem. It's like having a genie in a computer. Just make a wish, and poof, it's there. Then, in 2022, Google unveiled Phenaki, a model designed specifically for text-to-video. Phenaki could generate short video clips from text descriptions like a teddy bear painting a self-portrait or a spaceship landing on Mars. The results weren't perfect. Videos were often short and a bit glitchy, but they were a huge leap forward. It was like watching the birth of a new art form. But the real game changer came in 2024 when OpenAI launched Sora. Sora wasn't just another text-to-video tool, it was a revolution. With Sora, you could type in a detailed description like a futuristic city at sunset with flying cars and neon lights. And the AI would generate a high-quality photorealistic video up to a minute long. The results were stunning with smooth motion, realistic lighting, and incredible detail. The possibilities were endless. In 2025, AI is expected to make significant strides in healthcare, building on existing tools like IBM Watson Health and Google DeepMind's AlphaFold, which have already revolutionized diagnostics and protein structure prediction. AI-driven personalized medicine could become mainstream, offering treatments tailored to individual genetic profiles and improving outcomes for diseases like cancer and Alzheimer's. Autonomous vehicles, spearheaded by companies like Waymo and Tesla, are likely to achieve broader adoption, potentially reducing traffic accidents and reshaping urban mobility. In education, AI-powered platforms such as Khan Academy's AI Tutor could democratize learning, providing personalized instruction to students worldwide and bridging educational gaps. AI's role in combating climate change is also set to expand. By optimizing renewable energy grids, improving climate modeling, and enabling smarter resource management, creative industries will continue to embrace AI, with tools like OpenAI's DALL-E and ChatGPT, enabling new forms of art, music, and content creation. Quantum computing, though still in its early stages, may begin to enhance AI capabilities, solving complex problems in fields like cryptography, logistics, and drug discovery. Meanwhile, ethical AI development will remain a priority, with frameworks like the EU's AI Act ensuring transparency, fairness, and accountability. So where do we go from here? AI is still evolving, and we're only scratching the surface of its potential. Scientists are working on AI that can understand emotions, reason like humans, and even create original ideas. The future of AI isn't written yet. Will it become a true thinking machine, or will it always be just a tool? One thing's for sure, it's going to be one incredible ride.